Hello and welcome back to Mr. Powers Teaches Algebra. We are we're going to start talking about long division with polynomials. That be what we're doing. So what I got here are two problems. One is regular long division, one is long division, and there's polynomials. I'm going to do both, and hopefully you will be able to see some similarities between these guys. So 895 divided by 7. What was that? That was weird. 895 divided by 7. I think that's how we do it. All right. So first thing goes 7. How many times 7 go into 8? 1 time. 1 times 7 is 7, right? Put it down there. Subtract it. Make sure that 1 was above the 8. We get a 1. Bring down our next number, the 9. We could bring down the 5 also, but really I'm only worried about the first two, right? That 19. Now I'm thinking, well, how many times can 7 go into 19? I think it's 2. 3 would be too many. So 2 will have to do it since 2 works, right? And we know every time we subtract, we need to get something that's less than what I started with, right? So 19 minus 4 is 5. Great. That's less than 7. I'm doing great. Bring down the next number, the 5. And then, so how many times can 7 go into 55? I think it's 7 times. 8 would be 56, would be too big. 7 times 7 is 49. Subtract that, we get 6. That's perfect. Again, it's less than the 7 I'm dividing by. And so we can say that 6 is a remainder 6. Or we can say a couple things. We could have said also, instead of remainder 6, we could have said 895 divided by 7 equals, instead of 127 remainder 6, we could have said 127 and 6/7. That would work also. And another thing we could do is say, you know what? 895 equals 7 times 127 and 6/7. Means the same thing, right? Is your fact family. 6 divided by 3 equals 2. So 6 equals 3 times 2, right? Same thing. Same thing, okay? I'm not going to worry about that right now. And then one more thing I could do, and this is the one we're going to really focus on, is we could have said 895 equals 7 times 127 plus 6. And that's where we can see our quotient. Our answer was, how many times can 7 go into 895? It's 127 times. And then here's our remainder, right? So that's another way we can write it. And so we're going to focus on this a little bit for now. Okay? All of these are correct. All these are perfectly great. Now let's go ahead and look at the polynomial, long division with polynomials. So let's see here. We're doing 4x cubed plus x plus 8. And we are dividing by 2x plus 1. Okay, so the way we do this is we only worry about, there's one thing we care about, only one thing, and that is going to be, let's go with, there, the 2x. That's the only thing we care about when we're thinking about, hey, dividing 2x plus 1 into all this stuff, is we're only going to worry about the 2x. You know what? I forgot something over here. It's always a good idea to add place values that are missing. Like here we have 8 in our hundreds place, 9 in our tens place, 5 in our ones. Here I have 4 for my x cubes But how many x squareds do I have? I don't have any x squareds, but I didn't write 0x squared. And it's not really necessary, but it's a good habit to be in. It helps keep us from making silly mistakes. So you know what? I'm going to rewrite 4x cubed plus x plus 8 as 4x cubed plus 0 x squared plus 1x plus 8. There. I'm going to write it like that. Okay? And so when we do this division now, I only care, and let's see, we can't do that. Let's, this one here, about how many times can 2x go into 4x cubed. That's the only thing we need to worry about, is this greatest term, the term with the greatest degree that we're dividing, where our divisor is, that, and then our first highest term over here. That's the first thing we're looking at. Kind of like when I'm doing 7 into 8, 2x into 4x cubed. That's all I care about. So how many times can 2x go into 4x cubed? It would be 2x squared times. So 2x squared times 2x, you would do this just like normal. Multiply these, just like we do here. 1 times 7 is 7. 2x squared times 2x is 4x cubed. And that's our goal, is to get whatever this was exactly down here, right? But I got to keep multiplying, because I got to go 2x squared times this whole 2x plus 1, not just the 2x. So 2x squared times 1 is plus 2x squared. And then what do you got to do? We subtract it, right? So you got to be very careful when you subtract polynomials. And the way I like to do it is distribute the negative in, right? You could say minus this whole thing, but rather than do that, do the same thing. Just change the signs on everything. Negative, negative, and then add. So we're adding the opposite. It's the same thing as subtraction. So when I do that, we get 4x cubed minus 4x cubed. That's 0x cubed. That's gone. 0x cubed plus negative 2x squared. I'm sorry, 0x squared plus negative 2x squared is negative 2x squared. And then I still have the plus x and the plus 8. Bring all that down. Then we do the same thing. Keep going. So now I got, well, how many times can 2x go into 2x, negative 2x squared? Well, I think it'd be negative 1x. So I'll just say minus x. Well, it's negative x times 2x. That is negative 2x squared. And then negative x times 1 is negative x. And then subtract, just like we do over here. Then we subtract. So that means change the signs and add. So that's a positive now. That's a positive now. Change the signs and add. So that's cancels out. X plus x is 2x. Bring down the plus 8. All right. And now I got one more thing to do. How many times can 2x go into 2x? That's easy. One time. So I'll say plus 1. 1 times 2x plus 1 is 2x plus 1. Subtract it. So we'll change the sign on everything and then add. That cancels. 8 plus negative 1 is 7. So I get remainder 7, right? I could say there's my answer. 4x cubed plus x plus 8 divided by 2x plus 1 is 2x squared minus x plus 1, remainder 7. Or I could rewrite it a bunch of ways like I did over here. So let's check out those. What other ways are there? We could say 4x cubed plus x plus 8 divided by 2x plus 1 equals all of this. So we could say it's also the same as 2x squared minus x plus 1 plus 7 over 2x plus 1. Just like we did right here. Same exact thing. Or I could write it like this over here. I could say, you know what? 4x cubed plus x plus 8 equals 2x plus 1 times 2x squared minus x plus 1 plus 7 over 2x plus 1. Like that. Or I could write it with like the division with remainders. I could say 4x cubed plus x plus 8 equals 2x plus 1 times all that 2x squared minus x plus 1. And then we have our remainder of 7 plus 7. So there are the 3 ways I could do it. Again, this was my divisor. I think that's the word. My quotient. We could say remainder. Woo! Okay. So there they are. There's my remainder. Okay. All right. So there's long division with polynomials. Looks a little messier, but it's really, really the same thing. It's very, very similar to old long division. Very similar. Now, something to note is that the remainder, when you do long division, is always smaller than what you divided by, right? There's this relationship here between this and this. The 6 is always going to be less than the 7. Whatever the remainder is, it's going to be less than what we divide by. We also have the case here with our remainder and what we divided by. The remainder here is always going to have a smaller degree than what we divided by. So in this case, the degree of what we divided by, this was 2x to the 1 power. This was degree 1. And our remainder was degree 0. If you just have a number for a remainder, that's 0 degree polynomial. And so that's what we must always have happen. Our remainder must always be a smaller degree than what we divided by. So we got those kinds of things happening too. And so we just kind of switch our minds around on what we're thinking about. Okay. So let's see here. Maybe we zoom this out a little bit and we can fit that all in here so we can see this whole thing. So I'll end it really quick with the division algorithm, and then in the next video we'll go over some other things. So the division algorithm for long division is when a number a is divided by the number b, gives the quotient to be q and the remainder to be r, then a equals b times q plus r, where the remainder is can equal 0 or less than b, right? It's always less than. Our remainder is always smaller than what we divided by. This is, yes. So the dividend equals the divisor times the quotient plus the remainder. And that's what we had going on. Division algorithm for polynomials is very similar. If we have p of x and g of x, are two polynomials where g of x is not 0, right? Can't divide by 0. Then, okay, in this case, we're thinking like this. We're thinking p of x, actually here. Okay, we're thinking p of x divided by g of x. What do you get? So there's p of x will equal a g of x times q of x. So what we're dividing by times our quotient plus our remainder, where the degree of r of x, the degree of our remainder, is less than the degree of what we were dividing by, our g of x. Okay? So there it is in a nutshell. You don't really have to remember this. I won't hold it to you, the division algorithm for polynomials, but I think it's worth knowing, and it might be useful in the future. But we always have this be the case, that we can do this kind of division every time, and we will always get a result where the remainder is a smaller degree than what we started with. And just like in old division, if you want to check your work, how do you want to check it? It's really easy. I already wrote out how you check it the way you wrote it out. Multiply these two and then add 7. You should get this, right? Or take the 2x plus 1 and multiply it by this whole mess, and you should get what you started with. Just like old division. How do you check division? Well, multiply it back through. See if you get what you started with. So, all good things. I think that'll do it for this video. Till next time, enjoy doing math.